So for the next half hour, we're going to talk about quantum for power and utilities, and moderating the session is Pranav Gokhale. Dr. Pranav Gokhale is Infleqtion's VP of Quantum Software. He was previously the co-founder and CEO of Super.Tech, which was acquired by Cold Quanta in May 2022. Pranav has a PhD in quantum computer science from University of Chicago, where his research led to 3 Best Paper Awards, over a dozen publications, and 3 patents. His work spans the full stack, from low-level pulse optimization to compilation to fault-tolerant quantum algorithm design and benchmarking. We're thrilled to have him leading the session. I'll pass it to you, Pranav, for introductions. Thank you.
Great. Thanks so much for the kind introduction. My name is Pranav Gokhale, and I got the nice introduction here. I'll just mention Infleqtion works on building software-configured products at the edge, and because of that, we've been closely looking at the energy industry, which allowed me to meet these wonderful panelists today. So I'll go ahead and introduce the folks on the stage. First up here, we've got Dr. Mike Howard, who is the chair of the World Energy Council and the CEO Emeritus of EPRI, the Electric Power Research Institute, where he served as CEO and president from 2010 to 2020. Dr. Howard is a world leader in energy with 40 years of experience across the full stack of the industry, and he holds a PhD in engineering from the University of Tennessee. Next up in the middle, we've got Dr. Jeremy Renshaw, who is here from EPRI, and he leads the AI, quantum, and nuclear innovation disciplines, where he focuses on accelerating that R&D and connecting it to the energy industry. Dr. Renshaw has been with EPRI since 2012, and his previous roles included managing the used fuel and high-level waste group. And finally, last but certainly not least, we have Dr. Rozhin Eskandarpour, who is the founder and CEO of Resilient Entanglement, the first women-owned company in the quantum smart grid sector, and she is a senior member of IEEE and an adjunct professor at CU Boulder, bringing 14 years of experience in AI and power systems problem solving to the energy sector. So, Mike, I'd like to start with you if you want to help set the context here of what is the challenges and opportunities in the energy sector, where might quantum matter most?
Okay, well, appreciate it very much. So I've been in the energy space, and specifically the electricity space, for close to 4 decades. And what I thought I'd do is just kind of set the stage of why. Why is quantum so important to the electricity? And so we think about electricity, it involves the generation, it involves the transmission and distribution, delivery of the generated electricity, and then the end use, like for example, the lights. And the challenge is that it's critically important that we maintain 24/7 access to electricity. But with the increase in variable generation of electricity, with the increase of apps that we're able to control our access or use of electricity. Sitting here, I could adjust my heat pump at my house. There's a lot more dynamic nature that is occurring in the system. And all of this occurs at the same time that it is essential that you maintain the supply of electricity to equal the demand of electricity. That is a fundamental physics of electricity, and those have to be equal. And if they're not, if you have too much supply or too much load to where they don't equal, you end up with a major problem, which could result in a blackout. And so one of the things that the industry is doing is deploying millions of sensors, millions of touch points to have near perfect visualization of the condition of the system to make sure that the supply of electricity equals the demand of electricity. And then be able to reconfigure the system in real time so that those two things are equal. But things happen in the electricity space at much faster than the blink of an eye. And so you have to be able to control things much faster than what humans can intervene. And there's the problem. We have to be able to not only have perfect visualization of what's occurring today at any given second, but also to be able to predict what the future will look like, whether that's a second, a minute, or a day, so we can ensure the system is reconfigurable to make sure we have 24/7 electricity. And so the advantage of using quantum is that, one, you're going to have to analyze a tremendous amount of data, very high temporal speed, and to be able to predict. And so that's the challenge we face in electricity. So let me kind of stop there and then pass it back to you.
Perfect. Thank you for setting that stage. And with that, let me pass it to Jeremy to segue into talk a little bit about what EPRI is and how it plays a role at this intersection of energy and quantum, your existing activities here.
Yeah, thank you, Pranav. So EPRI is a nonprofit research institute. We exist for the public benefit. So we are not out there trying to compete with anyone. We win when we help to bring together the right groups of people to help the energy industry be successful, bring consistent, low-cost, safe, affordable, and clean energy to the masses. So that is why we exist, and that's why we're here. And now drilling down a little bit to the quantum space, so Mike set the stage really well on how complex the energy industry is, especially in the electricity sector. So we see so many different benefits from bringing together energy with quantum. So some of the things that we're doing at EPRI to be able to enable this is that we have a quantum interest group that we've developed that brings together experts from the energy sector as well as the quantum sector, including government organizations, NGOs, academia, as well as national labs. So we're trying to bring together the entire ecosystem to identify what are the highest value use cases, where can we bring people together to do proof of concepts, and how can we kind of get those early wins to set the stage and build from there. So you heard in the earlier session, they're talking a lot about how do we start up and grow businesses, and what we're trying to do is help all of those to succeed. So we at EPRI, we don't endorse any specific technology vendor or technology. We also don't disparage any. We are trying to be the tide that rises all boats. You heard that this morning from INQ as well. That's something that they're trying to do. So we're looking at bringing these communities together and really helping everyone to find the area that they can fit. And that's how we get a win, by helping others to do that. And one of the things that we're doing right now that's very exciting is a quantum challenge. So we're issuing a challenge related to how can we identify an area of use cases. So the one that we're actively working on right now is quantum sensors. So how can we identify quantum sensors that we can use, whether it's on grid applications, whether it's on power plant operations, or other end-use applications. But going back a little bit, we actually had a quantum challenge that we ran last year that was very successful. And that's part of why we're talking here today. So we had a quantum challenge on cybersecurity. And so we had a panel of experts across the energy industry that reviewed in a blind fashion a number of submissions. So we removed all names, company identification, and things like that. And surprisingly enough, we only allowed 2 submissions per company, and both first and second place came from Infleqtion. So I want to turn it back to Pranav to talk about the first and second place winners. And by the way, the third place winner was an individual contributor. So anyone can participate, whether you're associated with a company or not. So Pranav, we'd love to hear a little bit about what Infleqtion did that was so interesting that won both first and second place.
Yeah, well, thanks for that setup. So we certainly enjoyed participating in this challenge, and maybe I'll talk about one of our submissions, which is actually not in the quantum compute space, but on timing challenges in the grid. So one of the products we've been developing at Infleqtion is a optical atomic clock. It's a lot of words, but it basically means atomic clocks that are far more precise and far more accurate at sensing time than any other devices ever before at the scale of a box about this size, 3 liters. And with that technology roadmap that we have on the clock side, we're able to figure out ways to make the grid more resilient, both in the event of GPS denial. It turns out that the grid is inherently tied to the presence of GPS signal, which can be easily spoofed or denied, as well as actually enabling new levels of control accuracy in the grid, enabling applications like droop control, where you can let generators stray from their natural frequency to enable better power management. So that was kind of on the clock side what we've been really excited about and are looking to continue building relationships with the energy industry on. On the compute side, I'd actually like to turn it over to Dr. Rozhin Eskandarpour to talk a little bit about where you see the highest potential applications in quantum compute applied to the grid, as well as where you see intersections between quantum and AI for the grid.
Thank you, Pranav. These are excellent questions. To answer this question, I would like to answer this question through 3 consecutive steps. First, we talked about the challenges. I would like to picture the ideal power system that we are actively looking for to achieve. Second, I will talk about the role of quantum computing in helping us to achieve this goal. And third, I will talk about the power of quantum computers to solve this problem. What is an ideal power system that we are trying to achieve for solving the current challenges? In an electric power system, the fundamental pillar is ensuring safety and security. Around this fundamental pillar, there are 3 pairs of attributes. These are that an electric power system must be resilient and reliable, clean and sustainable, equitable and affordable. And the main goal of all grid operators is to maintain the balance between these attributes around the basic pillar. So what is the role of quantum computing? The role of quantum computing is to help us to maintain this balance while ensuring the highest security and resiliency in the system and the lowest cost of electricity for both grid operators and customers. However, it requires solving a set of critical and complex optimization problems. These are large-scale, nonlinear, and NP-hard problems with many equations and variables. And quantum computing has attracted many attention as an emerging and promising technology to tackle these current challenges. To explain what is the power of quantum computers in solving the current challenges, let me explain through one example. Through the past couple of years, around 3 years ago, we have started working on one of the major problems in power system. It is defined by Department of Energy and QEDC as one of the most critical problems that can be solved using quantum computing and called contingency analysis. We saw in current practices, this problem can be solved for one component outages in the system. I would explain that this problem represents the ability of the system to maintain the reliability and balance in the system even in case of multiple component outages in the system. So every 1 to 5 minutes, the grid operators solve this problem to maintain the reliability. But they are facing significant challenges to solve this problem for 2 or more component outages in the system. Sometimes it takes from minutes to days to find the solution. We solved this problem using quantum computers. And it is so interesting to mention that it doesn't matter if we have one component outage or multiple component outages in the system, it takes 5 seconds to find the best solution. That is the reason we continue focusing on this field of research and development, and it has attracted many attention by energy sector.
Very eloquent. I'll maybe turn it back over to Mike and Jeremy to react. Also, any reflections from the workshop that you had on Monday for applications that seem exciting, including contingency analysis.
So as I was sitting here listening, I was trying to come up with maybe a sentence or two to really describe the challenge that we're facing in ensuring that we have 24/7 electricity. And I think it really comes down to it's a network optimization and contingency challenge where you have millions and millions of data and touch points along the entire electrical system. And so how do you optimize that? And how do you think about various contingencies that could happen? A pole falls, and you lose maybe a distribution or transmission cable. Well, you have to reconfigure the system, so you have to re-optimize it. But it's not just optimizing and reconfiguring at this particular point in time, but it's also about predicting what might happen into the future so that your assets that you have available are able to be reconfigured to address any particular contingency. And this is a huge problem. But if we're going to move to a world where we can decarbonize our energy system, we have to have a system, a network, that is much more flexible, much more predictable, much more manageable at the speed that human intervention will never be able to match. And so you have to have something like quantum with AI to be able to manage the system. So I think that's really what it comes down to.
Yeah, and I completely agree. And the two words that come to mind for me are resiliency and reliability. Because if we look around, and the other part of my job is looking at AI, as Mike had mentioned. So we're very interested in what AI can do for the grid, as well as power plants. So if you look at, let's say we have 99% reliability in an AI system that's designed for sales and marketing. That's a big win. If you have 99% reliability in predicting who's going to win the Super Bowl, that's amazing. If you have 99% reliability in the grid, that's a huge loss. That's a huge miss. That's 14 to 15 minutes per day of not having electricity. Who would like to have that? Anyone? So I see 0 hands right now. No one wants 99% reliable electricity. So lower is better, right? No, I'm just kidding, of course. So 99% is not nearly good enough. We need to be reliable, we need to be resilient for all kinds of different things that can happen that we can't plan for. You have a squirrel that's running along a line and jumps between lines and shorts out your system. You have a drunk that's driving and hits a power pole. You have a lightning strike, because lightning loves to hit power transmission equipment. So we have all of these different things that can happen. I mean, a wood power pole looks a lot like a tree to a woodpecker, so guess what? They drill a lot of holes in. And we have to be able to adapt to all of these different unforeseen circumstances where any part in your system can go out at any time for a number of situations that are beyond your control. I mean, heck, in North Carolina, where I live, we had some people that went and shot up a substation. How do you plan for that? Well, You can't exactly plan for it, but you can have resiliency measures in place to adapt to it. And so going back to what Rozhin said, we really need systems like that that have quantum computing enabled with AI and other advanced computing systems to be able to identify, okay, this part of the system went down, how do we reroute power to minimize or eliminate any blackouts, brownouts, keep the reliability high, and be able to maintain that flexible, resilient system that Mike had mentioned.
So, Rozhin, as someone who's been on the forefront of interacting with utilities, if you could summarize some of your experiences, I guess dealing with utilities is very different than dealing with almost any other entity out there, would be great.
That's so true. Actually, we had the fortune to start our research and development through close collaboration with one of the major utilities in the U.S., Comet utility. And our initial studies, we started by solving one of the fundamental problem in power system called power flow. Power flow is the keystone of utilities decision making in planning, operation, and control. So after doing the proof of concept through this collaboration, we plan to expand our research and development and solve other related problems, with the goal of solving the most critical optimization problem in power system planning and operation, which is called security constraint unit commitment. Through the past several years, we've been able to solve a wide range of problems to achieve this goal. And we are honored that we had a chance to collaborate with Pranav, Infleqtion, University of Chicago, to start this field of research and development. So it's been challenging because our mission is to accelerate the adoption of quantum technology by energy sector, help them increase the security, resiliency, and sustainability of the grid. I would share this news that it has attracted many attention by utilities and ISOs. Besides Comet utility, we started our collaboration with other energy sectors and independent system operators. They are interested in investing this technology, and they've been so supportive to tackle this problem together. But 100% I agree that it's been so challenging because of the culture of utilities and ISOs, but now we see that they have opened the doors for collaboration.
So as we wrap up, maybe just one last piece to mention. We've talked about quantum computing a fair bit. I've mentioned atomic clocks, and I think it's also important to mention quantum sensing as a third piece of the trifecta of what quantum technologies can do. On our side, we're developing magnetometers, gravimeters, inertial sensors, and QRF, quantum radio frequency, and there's a lot of very near-term potential there. And on that note, Jeremy, if you just want to say a word or two about the new challenge that you've launched and raise awareness for it, I think this is a good venue.
Yeah, thank you very much, Pranav. So, per the comment that I made earlier on how are we trying to bring the two industries, energy and quantum, together, we've identified a number of challenges that we're releasing over the years. So we had our cybersecurity challenge last year that Pranav and Infleqtion won. We currently have a challenge going on for quantum sensors, looking at how can we apply new advanced sensors to the grid, to power plants and other energy generation and utilization assets. And as a teaser for the future, we have two challenges that we'll release next year, one related to quantum for fusion, which is very exciting, and another for quantum and machine learning, which you've heard about at this conference. So we're very excited to see where these go, and we think that there are a lot of opportunities to bring these two industries together around quantum and energy.
So to close, Mike, if I can put you on the spot, if you want to synthesize and reflect in a minute or so of what you've heard today and what you've heard this week, and what your call to action might be for quantum and energy.
So the energy space is fundamentally important to every single person on this planet. There's a huge opportunity to use these technologies to help ensure affordable, reliable, sustainable, resilient electricity. And so I would challenge everyone here to think about the applications here and think about how you can deploy these technologies to the benefit of every person on this planet. And then in closing, I would like to say that EPRI is an organization that's been around for over 50 years. It's a not-for-profit. It's there to help bring these new technologies to success. And so the website is EPRI.com. And if you're interested in this space, I would highly encourage you to get to know Jeremy and some of the things that EPRI's doing. Thank you.
Great. Thank you so much to my co-panelists and to the audience. We're all on LinkedIn, and you're welcome to connect with us there. Thank you.
Great, thank you.